Hello. There seems to be a problem from the network operators here. How's the video? Is it standing up right now? Is the video up right now? Let somebody send me that note. Is it upright? Please. How's the camera? How's the video production? Okay. How is it now? Is inverted? The video is inverted. How come? Inverted as how? How is the video? The camera is inverted. How is it now? Can you hear me? Can you hear me? How is the camera now? How is it now? How is it now? How's the camera production now? How's the camera production now? Is it okay? Still inverted. How is it now? Is it okay now? Is it okay now? Is it okay now? You can't see the board. How is it now? How is the camera now? Okay, don't worry. I think something is wrong somewhere here. Can you see the board now? 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 Can you hear me too? Can you hear me too? Okay. How is it like this? How is it like this? Is it okay? I will write something on the board. How is it like this? Is it okay now? Is it okay now? Is it okay now? Is it okay now? Can you see me? Can you see me? Can you see the board? 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 Hello, students. Hello. Can you see the board? Okay. Shall we continue? Shall we continue? Shall we continue? Hello. Okay, now, if that has been said, apology for the mistakes committed. It's always like this when you first start this kind of journey. So please apology for these mistakes. Okay. Now, what we've been discussing is this is a review of what we've learned before. A review of what we have so far been taught in the course called calculus. Now MTS 102. Now here we want to look at some topics that we have learned previously. So we want to look at some topics that we have learned previously. Now we started with functions of real value variables, and their graphs. So we were taught how to plot the graphs and what we meant by functions. What we meant by functions. Okay. Now I was citing an example. I said, suppose we have two non-empty sets, X and Y. Okay. Just like saying that you have two prospective couple. This is the this one is called the lady, and this is the young man. Okay. Now this is the spinster and this is the bachelor. Now, if they are on their way, they want to connect together, there must be somebody that will bring that connection. Just like as we usually have in the past, when our parents are trying to woo someone they call their own. So that thing is called a function mathematically. The function relays the message from X to Y. So the function is acting as the intermediary between X and Y. So X is called the domain of the function, Y is called the codomain of the function. Okay. Now, what you simply mean is this, that every element in X must have a corresponding element in Y. Okay. Every element in X must have a corresponding element in Y. So that's why F is the intermediary between X and Y. So now we actually want to look at some questions that we feel we should review again concerning this course, so that when we come across them in the tests and exams, they will not be too difficult for us to solve. And mind you, going through the previous videos on tutorial review will do you a lot of good. So watch them and watch and watch and watch and watch. So by the time you watch and rewatch severally, you will you have the mastery of what you have been taught in those topics. But for today, because of our time, let's quickly look at few questions from some of you who have put up this question. We can put up some of the questions who have put up some of the questions we are talking about today. So we have express, the first question is express 2.25 radian in degree and minutes. Express 2.25 radians in degree and minutes. So now this is a very good question in trigonometry that we have learned. Conversion from radian to degree. What you just need to do is 1 radian, is equals to 180 degree all over pi. You have to bear that in mind. And so 2.25 radian will now be 2.25 radians will be 2.25 multiplied by 180 all over pi. Your pi here will be 3.142. So by the time you find the calculation, you are going to have 128.89. Okay? But remember, we are asked to convert it in degree and minutes. So this is already in degree. How do you now convert it to minutes? Fine. What you just need to do is take the decimal portion of this value, which is 0.89, multiply it by 60. So you are going to have 53.4. That's what we have. So now take the whole numbers from this value, add it to this one. You have what? 128.53. You have already taken this one out to when you are multiplying. So you now have 128 degree, 53 minutes. That's it. That's how to go about that. Okay. Now, let's look at another question of interest. Another question of interest. Let's look at another question of interest. Now, if y is equal to tan x, then the square y all over the x square is what? That's a question for us. That's a question for us. That's a question for us. Okay? That's a very good question for us. Now, I hope you are listening. If you are listening, let me hear you. If you are listening, if you are getting it, let me hear. Please send a message to me that you are listening. I want to hear you. Send a message to me that you are listening. I can't see your message. Send a message to me that you are listening. Send a message to me that you are listening. Can you hear me? Are you getting it? Are we good to go? Okay. Were you seeing the board before? Were you able to see the board before? Let me hear. Were you able to see the board before? Were you able to see the board? Were you able to see the board? I want to hear from you. Okay, you're able to see the board. Am I good to go? All right. God bless you. God bless you. That's good. That's my children. Those are children. Now, if y is equal to tan x, then the square y dx square is what? Now, first of all, what we're going to do is that you differentiate y with respect to x. You remember what you are asked to find there is the second degree of your differentiation. So the first degree will give us what? The y dx will be sec square x. That is the first degree. When you differentiate tan x, you get sec square x. Now, but the question says you should find the second degree. That means you will differentiate again. So we can interpret this and say that this is the same thing as what? Sec x, all square. Yes. Sec square x means sec x times sec x twice. So this has given us an element of what we call what? Function of function. Okay? Now, by differentiating this again, so now what? The square y all over the x square. That will give us what? Multiply the 2 here, take the 2 here, you have 2. Then differentiate what you have in the bracket, sec x tan x. Please note, anytime you differentiate sec x, you get sec x tan x. Then now multiply by what you have in the bracket again. That is sec x. That's the logic. Instead of you wasting your time assuming that let x equals to this and that. No, don't stress yourself. This has given us an element of function of function. Now take 2 to multiply this, you have 2. Then differentiate sec x, it will give you sec x tan x. Now multiply by what you have here. Okay? But see, this one is sec x raised to power 2. If you subtract 1 according to the normal differentiation principle, if you subtract 1 from 2, you have 1. So you'll be left with sec x. Suppose we have sec qx. So let's say what we have here is 3. And you have brought this 3 here, you write 3 here, you differentiate sec x, you get sec s tan x. You now take 1 from that 3, it remains 2. So this one will be sec square x. I hope you understand. But because this one is 2, when you take 1 away from it, you're having a sec x. So multiply out, you have 2 sec square x tan x. Now, and since we have an element of tan in here, in the given problems, we can rewrite sec square x in form of tan. You note that. Note. Sec square x is equal to 1 plus tan square x. So that means we can replace this sec square x with 1 plus tan square x. So that will give us what? That will give us the square y now all over the x square will be 2 into 1 plus tan square x multiplied by tan x. Now fixing, you have 2 into 1 plus. What do you mean by fixing? What do we have in the problem? We are told that y is equal to tan x. So now return y there. You have y squared multiplied by y. Okay? Because tan x is y. And you're having tan square x there. So that will be y squared. So which is going to be, by the time you expand, you have 2y into 1 plus y squared. So that solves the problem. It's as simple as that. I hope you got that. If you got that, if you understand that, if you understood that, let me hear you. Did you get it? Did you get it? Okay, you can't see the other side of the board. Don't worry, I will adjust that. I will adjust that. How is it now? How is it now? How is it now? Can you see the other side of the board now? Oh, you can't see the other side of the board? What about this? How is it? Can you see it now? Can you see it now? Can you see the other side of the board now? Can you see the other side of the board now? Okay, I should start again. I should start again. Ah, sorry about that. Okay, let me start again. You are my children. I have to try as well as possible to please you. You must do well. You must do well. You must do well. You must do well. Yes. Can you see? Can you see? It's okay. Are you the wrong way? Ah, okay. You said shifted to the wrong way. How about like this? How about like this? How about like this? How about like that? It is worse. Ah, this is terrible. This is terrible. How is the positioning now? How is the positioning now? How is it now? It's too much. Too much to the left. Perfect. It's okay. Thank you very much. Thank you very much. Thank you very much. So with this now, what I just did here is, if y is equal to tan x, the question says you should find the square y over the x squared. And I said, okay, in this case, we are asked to find the second derivative of y. That's why we have the square y over the x squared. The higher derivative of y, the y, the x. Second derivative. It is a 3 now, it will be third derivative. So first of all, differentiate y with respect to x, you get sec square x. Anytime you differentiate tan x, you get sec square x. So you have sec square x, and sec square x will now be written as this. You can write sec square x as sec x all squared. Okay? This one has given us an impression of what we call what? Function of function. And now to solve this, to differentiate this by function of function, you don't need to stress yourself. Now that you have obtained that dy dx is sec square x, which has been written like this, differentiating it again, you have the square y over the x square will now be, bring 2 here, your 2 times 1 here is 2. Then differentiate sec x that you have here. It will give you sec s tan x. Then now, again, this sec s, subtract 1 from the power, from the index. You have, when you subtract 1 from 2, you have 1. So that's why we have sec x here. Now that we have this, multiply everything out. Sec s tan sec x will be sec square x tan x. And we know in our identity, sec square x here, if you want to write it in form of tan x, it's the same as 1 plus tan square x. So that means here that we have sec square x, we can replace it by 1 plus tan square x. So having replaced it by tan square x, then we have this. But from the original problem, y is said to be tan x. So that means wherever we see tan x, we write y there. That's why we now have 2 into bracket 1 plus y squared multiplied by y. So bringing y here, you have 2y into 1 plus y squared. I hope that is okay. That's okay. Do you understand that? Are you still with me? Are you with me? Are you with me? Let me see you say yes. Are you still? Is it okay? Did you get that? Did you get? Very good, very good. Let's continue. Let's continue. Very good. Let's continue. So let's look at a few more examples or a few more questions. Let's look at a few more questions. Let's look at a few more questions. Let's look at a few more questions. Now let's look at a few more questions. So we are still going to consider questions from applications. Let's consider question more from applications. Okay. Now applications. A pipe. Are we still okay? Are we still okay? Thank you. Thank you. We are given that a pipe delivers, the volume of water the pipe delivers is Vm cube. That's the volume of water delivered. In t seconds, that's the time. Then the connection, the equation that connects that is V is equal to 12t minus t squared all over 10. Okay, this one can be written as you can write it as 12t 10 t squared. Fine. So the question I asked, at what rate is the water delivered after 5 seconds? Are we following? Are we following? Are we following? Say yes. Okay, beautiful. If you are following, beautiful. Now, To get the rate of the deliverance of water now, that is the rate at which the water is delivered from the pipe after 5 seconds. First of all, let's differentiate this V with respect to T. The V dt will be, 1 times 12, 12. T will disappear because it will super 0. Then minus 2 times 1 over 10, 1 over 5, then T. Okay, that is that. About that. We have differentiated the V with respect to the T. Now the question says, after 5 seconds, what will be the value of the rate at which the water is delivered? That is, when T is 5. So dV dt will be 12 minus 1 over 5 times 5. Okay? 5 cancel 5, that's 1. That will be 12 minus 1. So dV dt will be 11 meter cube per second. So that is the answer. It's as simple as that. It's as simple as that. And do you understand that? Is it clear? Can you understand? I want to tell you, did you see that one? Okay, thank you very much. Thank you, Adenubi. Thank you, thank you, thank you, thank you. Inioluwa, thank you. Thank you very much. Thank you very much. Let's continue. Let's continue. Let's continue. We don't have much time. We don't have much time. Apology for wasting our time before. It was due to technical issue from my hand. So sorry. So sorry. Now, here's another question. Here's another question. Here's another question. We have the slope of the curve y squared minus xy minus 3x is equals to 1. At the point, we want to find the slope at the point 0, minus 1. So this is straightforward. It's asking you to find the y dx. But this is an implicit function. You can see y and x are written together. It is implicit. Unlike when you usually have y is equals to something, but this is a combined form of y and x. So it's implicit. So you now differentiate implicitly. And to differentiate implicitly, anytime you differentiate y, you must multiply by dy dx. So let's differentiate. 2y dy dx minus, now we are through with that. This is a product of x and y. You keep one, you differentiate the other. You keep one, so that's it. Let's keep x first. S. By the time we differentiate y, it will be 1. Multiply 1 by dy dx. You have dy dx. Then plus, yes, plus the minus, because the expression is having minus. This plus is natural from product rule. This plus is from product rule. Okay? Now, we have differentiated y. You now keep y now, we differentiate x. When you differentiate x, you have 1. Okay? Minus, now differentiate 3x, you have 3. Okay? Is equal to, when you differentiate 1, you have 0. I hope you understand. Fine. So you have 2y dy dx minus x dy dx minus y minus 3 equals to 0. So you have what? 2y dy dx minus x dy dx is equal to 3 plus y. Want to rearrange. And you observe clearly here that dy dx is common. Okay? So dy dx can be factored out. So you have what? 2y minus x is equal to 3 plus y. Now, how do we now get dy dx? Divide both sides by 2y minus x. So you have dy dx is equal to 3 plus y all over 2y minus x. Yes. If you divide both sides by 2y minus x, this one come here, it will be under 3 plus y. Now, at the point 0, minus 1, at the point 0, minus 1, we are asked to find the slope. So that means 0 is for x axis and minus 1 is for y axis. So now substitute, you have dy dx is equal to, okay, 3 plus our y is minus 1 all over 2 into minus 1 minus 0. Because x is 0, y is minus 1. So you have what? 3 minus 1. That's because 3 plus times minus is minus all over minus 2 minus 1 times 2, that's minus 2 minus 0. So that will give us what? 2 all over minus 2. So the y dx now, that is the slope, will be, because minus times plus here is minus, 2 cancelling 2 is 1. So the answer here is minus 1. So the answer there is minus 1. I hope that is gotten. Do you understand that? Is that clear? Is that clear? Okay, is that clear? Are you getting it? Beautiful, beautiful. So let's look at another question. Let's look at another question. Please don't be tired, don't be tired. Don't be tired. Quitters never win and winners never quit. We'll soon round off, please. Don't be tired, please. Don't be tired. We'll round off soon. Okay? Now, this is another question. This is talking about maximum and minimum values and the point of inflection. We have to find the maximum and minimum value at the point of inflection. We have the equation is y is equal to x cubed minus 6x squared plus 9x plus 1. So we want to find the maximum and minimum values at the point of inflections. Okay, now, given this polynomial equation, we first recall that at the point of inflection, you know, the y dx is equal to 0 at that point. So that means we need to differentiate this function. Okay, differentiating now, we have the y dx will be 3x squared, you know, minus 12x plus 9. Now, since at that point, it must be equal to 0, so that in case is equal to 0. Now, the next thing is to factorize. We factorize 3x squared, you know, multiply this 3x squared by plus 9, you have 27x squared. So look for the factors of 27 that will give you 12. You have 3 and 9 rather, 3 and 9, minus 3, minus 9 minus 3, plus 9 plus 3. So we can use any of this. But because we are having minus sign as our middle term, we pick minus 9x minus 3x. So we have 3x squared minus 9x minus 3x plus 9 is equals to 0. Okay? Now with that, we factorize out. So 3 is common. 3x into what is left here? X minus 3. Then minus what is common to this and this? You have 3 into x minus 3 is equals to 0. So you now connect 3x minus 3 into x minus 3 is equal to 0. Okay? So equate each of them. 3x minus 3 is equal to 0. That will give us 3x is equal to 3. By the time you take 3 to the other side. So x will be 3 over 3, which is equal to 1. The next one, x minus 3 is equal to 0. X will be equal to 3. So our x is 1 or 3. Now, how do we now know which point is maximum and which point is minimum? Now, at minimum point, the square y over the x square must be greater than 0, while at maximum point, let me write this one here so that you'll be able to see. Let me write this clearly here. Let me write it here. Let me write it here. Okay. At minimum point, the square y over the x square is greater than 0. At maximum point, the square y over the x square is less than 0. That means we have to differentiate once again. Let's differentiate again. When we differentiated first, we got the y dx is 3x squared minus 12x plus 9. Differentiating again, you give us what? The square y all over the x square, which what? 6x minus 12. Now let's check. Let's check when x is equals to 1 and when x is equals to 3. Let's check when x equals to 1 and when x equals to 3. Oh yeah. At x equals to 1, the square y over the x square will be 6 times 1 minus 12. That will be 6 minus 12, which is minus 6. Okay? At x is equal to 3, the square y over the x square will be 6 times 3 minus 12. That is 18 minus 12, which equals to 6. Fine. Now let's examine, let's check. Which of these satisfy the condition given? Now we have the square y over the x square is minus 6. So which is less than 0? Because minus is less than 0. That means at x is equals to 1, the square y, that is we have the square y over the x square is less than 0. And that is the maximum point. Because at the maximum point, the value must be less than 0. The value of second derivative. And at x equals to 3, the square y all over the x square is greater than 0. So that means at x equals to 3, we get a positive value, which is more than 0. So that point is the minimum point. Why the maximum point is gotten when our x is less than 0 at point x equals to 1. At point x equals to 1, we have maximum, and at point x equals to 3, we have minimum. So that is that's about that. Because we have taken much of our time today, we probably want to shelve this class to another time, so that if we have more problems before Monday, we'll come back and discuss. So, if you have any question concerning what we have done today, you can channel your question to my Gmail, so that in the next class we discuss that. So if you want us to have another session tomorrow, please send the information to the Gmail so that we discuss more on this. But by and large, if we don't have the privilege again online tomorrow, I would advise that you go all over the videos that have been uploaded for you, particularly tutorial review, look at them once again all over, check them, try them yourself, lay your hands on the exercises, practice them as much as possible, and I believe by the grace of God you'll do well in your exam and test. Meanwhile, if you still want us to meet, let me know. I want to know your view. But before I go, I want to apologize for the technical itch that we experienced when we actually started. It wasn't my making. It was due to some logistic problems. And I hope I will perform much more better in the next online presentation. Thank you very much. Stay blessed and enjoy your weekend. God bless you all. God bless you.